Hi friends, how are you? I am your friend and guide Subodha. So today we'll discuss about the topic polynomials. Polynomials. So poly means many terms. So before we are going to discuss about polynomials, we will understand the basic facts about the polynomials. What a polynomial is. So now we'll discuss about what a polynomial is. See, a polynomial is an expression. Polynomial is an expression. So expression, how are you? It is an expression. It is an expression. What? Verbal expression. But if I will say mathematical expression, in mathematics, what type of expressions we are writing? Let us see. Suppose I will tell 4x plus 2, 2x square plus 3x plus 4. So these are all one expressions. So then what is expression? Expression, it is a single term or a group of terms. Expression, a single term or a group of terms. So now single term like your 4x or a group of terms 4x plus 2, 2x square plus 3x plus 4, group of terms. Now terms. Now come to terms. Terms are basically of two types. One is constant term, another is variable. Constant and variable. Constant and variable. Suppose I will say 5. Show me your 5 fingers. You will say 5 fingers. If I will say show me your x fingers, someone may say this is x. Someone may say this is x. Someone may say this is x. So varies from person to person. So named as variable, constant and variable. Now, so according to this constant and variables, we are telling that the polynomial is an expression consisting of variables and coefficient, constant coefficient that involves only the mathematical operations such as plus, minus, into, and non-negative and non-fractional integer exponent, power, degree of variables. So let us see one by one. We will discuss about all these things. So now, first of all, we should know the expression and equation. What is the difference between expression and equation? Suppose this is 4x expression. Suppose given 4x is equal to 8. This is equation. This is your equation. When there is a equal sign, there is a equal sign that makes the expression an equation. So now we have idea about terms, expressions, equation. 4x is equal to 8. Suppose given 2x plus 3 is equal to x plus 9. This is also, we know in junior classes, linear equation in one variable. So now move on to the topic polynomials. Now we'll discuss about polynomials. But before going to the polynomials, we should know about the degree. What is the degree? Degree generally we are telling it power. degree of polynomial. Degree of polynomial. Degree of polynomial. Suppose given 4x. What is the degree here? Degree of x is 1 because x to the power 1 is x. Now 4. Here is there any variable? No variable. No variable. Is a constant term. But 4 is equal to, I can write 4 into 1 is equal to 4 into x to the power 0 or any variable to the power 0, or I can write or 4 into y to the power 0 or 4 into z to the power 0, any variable to the power 0, anything to the power 0 is 1. So here I can say 4 is also a variable. But that is a constant, we are telling that is a constant. Then what we will say? That is question number. Your 1 point, that is called constant polynomial. But non-zero. Zero not excluding 0. Non-zero constant polynomial. Non-zero constant polynomial will say non-zero constant polynomial. 4, 5, 20, 30, whatever this may be, constant polynomial, non-zero constant polynomial. Now we'll move on to the next part. But before it we are discussing about the degree. Degree means highest power. Suppose I write here 4x. What is the degree? 1. Now here 4x 2x square plus 3x plus 4. Here degree is equal to 2. That means degree means what? Degree. Highest power of the variable. Highest power. The maximum power of the variable is that degree. Now given 3x cube plus 2x square plus x plus 1, then what will be its degree? Degree is equal to 3 because highest power of x is 3. Here highest power of x was 2. So degree 2, degree highest power of variable, highest power of variable. So degree 2. Now using this degree, we have divided the polynomials into 5 major categories. What? Already I have told you one, non-zero constant polynomial. Now number 2, linear polynomial. Number 3, quadratic polynomial. Number 4, cubic polynomial. Number 5, bi-quadratic polynomial. So now move on to this types of polynomials. Types of polynomials. See, if I write x to the power minus 1, x to the power half, x, 4x. From this, which one is a polynomial and which one is not a polynomial? So from the definition already we know the polynomial is an expression consisting of what? Variables and coefficients, constant. Variables and constant. Variable and constant. Coefficient 4x. Coefficient of x is 4. That is a constant term. So constant into variable. 4x. We are telling constant into variable. That involves only the mathematical operations such as plus, minus, into, and non-negative and non-fractional integer. That means exponent of the variable cannot be negative, cannot be a fraction. But why not? So x to the power minus 1 is equal to 1 by x. x to the power half, we can write this is root over x. Already we know in the junior classes these are. So the degree of the variable cannot be negative and the degree of the variable cannot be a fractional number. So it should be a whole number. Degree of the variable, degree of the variable must be a whole number in a polynomial. In a polynomial must be a whole number. Okay. Now move on to the different types of polynomials. Different types of polynomial. Already I have told you about one type of polynomial, that is your non-zero constant polynomial. Now move on to number 2, linear polynomial. Linear polynomial. Linear polynomial means degree 1. Degree 1 was given x plus 3, or I can write 3x plus 2. This is a linear polynomial. This is also a linear polynomial. Degree 1, x to the power 1. Here also x to the power 1. So this is a linear polynomial. Then we are writing different examples. What is this general form? General form. General form is ax plus b. General form is ax plus b of a linear polynomial. Now move on to second one, your quadratic polynomial. Quadratic polynomial, that is degree 2. This is degree 1, this is degree 2. Degree, highest power of variable 2. Quadratic. Suppose given 2x square plus 3x plus 4, comma. Suppose given 5y square plus 3y minus 2. This is a quadratic polynomial. This is also another quadratic polynomial. Why? Because highest degree is 2 and written in the descending order of power of x. Written in the descending order of power of x. Okay. Now, what is the general form? General form is your x square plus bx plus c. Here one thing you have to note it down very carefully. General form of linear polynomial is ax plus b. But here, comma, a is not equal to 0. A cannot be 0. A cannot be 0. Here also, a is not equal to 0. Here also, a cannot be 0. The variable constant or the coefficient of the degree giving variable, the variable which gives us degree, cannot be 0. That cannot be 0. Now b may be 0. Here BC may be 0, but A cannot be 0. A cannot be 0. Now come to third one, cubic polynomial. Cubic polynomial. Cubic degree 3. So suppose given 3x cube plus 2x square plus x plus 5. Here one example is given. Here is degree. How much degree? Degree is equal to 3. Because x cube, highest power variable x cube. What is the general form? General form is your x cube plus bx square plus cx plus d come on. A is not equal to 0. A cannot be 0. I have told you A cannot be 0. Here B, C and D may be 0, but A will never be 0. Now the fourth one is your that is your bi-quadratic polynomial. polynomial, bi-quadratic, degree 4. So suppose given ax to the power 4 plus bx cube plus cx square plus dx plus e. This is given. Degree 4. Degree 4. Now here general form. This is I have given. A to the x. This is your general form. General form. Suppose I write 5x to the 4 plus 4x cube plus 3x square plus 2x plus 1. This is a bi-quadratic polynomial. But bi-quadratic polynomial is not in our syllabus. We will not discuss more about it. Only we will restrict ourselves into linear polynomial, into quadratic polynomial, and to cubic polynomial. Move on to the next. Zero of the polynomial. 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 Now to understand what is the zero. First, the definition. A real number. A real number which makes a given polynomial zero is called its zero. A real number which makes a given polynomial zero. So real number which makes a given polynomial zero. So until and unless we assign a value to the variable, we will not find the value of the what? Polynomial. So until and unless we assign any value to the variable, we will not get the value of the polynomial. So first see, before finding the zero, we say until and unless we assign any value to the variable, we will not find the value of the polynomial. So what is this? Let us discuss about it. So take an example. Let's say what px, a polynomial in x. Px, a polynomial in x. So let px is equal to 3x minus 6. I have taken. Now I will take different value of x. Suppose I will take x is equal to 1. X is equal to 1. So p1 is equal to 3 into 1 minus 6 is equal to 3 minus 6 is equal to minus 3. Now p2 is equal to 3 into 2 minus 6 is equal to 6 minus 6 is equal to 0. So I can write p2 is equal to 0. p2 is equal to 0. So now for which value of x? For which value of x the polynomial px becomes 0, is called its 0, is called its 0. Now a real number which makes a given polynomial 0 is called its 0. Now you can understand from this example that how we are getting the 0 by taking one example. Now we'll discuss more about it. So Uh, let us see. So we can say, so a real number, let's say k, is called the zero of a polynomial px if pk, let's say p capital P, pk is equal to 0. pk is equal to 0. Suppose given 3x plus 4. Take one example. 3x plus 4. Px is equal to 3x plus 4. Now I can write how to find out the 0. Now I can write the pk is equal to 3k plus 4. Substituting x by k. Now how we are getting the 0? By equating it into 0. So I can write 3k plus 4 is equal to 0. That implies 3k is equal to minus 4. That implies k is equal to minus 4 by 3. So the value of k is minus 4 by 3. So minus 4 by 3 is a 0 of the polynomial. What? 3x plus 4. Now, so in linear polynomial, general form, what? Ax plus b. What is a? A coefficient of x. B is your constant term, or the term without having variable. Now here a is not equal to 0. B may be 0, but a is not equal to 0. Now in general, if I will find the 0 of a linear polynomial, so I will find ak plus b is equal to 0. Right? pk is equal to ak plus b. pk is equal to ak plus b. So ak plus b is equal to 0. That implies ak is equal to minus b. That implies k is equal to minus b by a. Minus b by a. So what we can write? K. So 0 of a linear polynomial is equal to minus b by a is equal to minus, what is b? Constant term, okay, by a coefficient of x, Now let us verify whether we are correct or not. So here our 3x plus 4 is the polynomial. Px is equal to 3x plus 4. Here this is your a, this is your b. Now we have got one root minus 4 by 3. Root is minus 4 by 3, already we have obtained. So see, minus constant term is b, here 4, and coefficient of x a 3. So minus 4 by 3. That from this formula also we are getting that is equal to minus 4 by 3 according to our example. So this is verified that the zero of a linear polynomial you can find out by using the formula minus b by a. Now move on to the next geometrical meaning of the zeros of a polynomial. Geometrical meaning in geometry, in a graph. How can we find out the zero of a polynomial? So let us discuss about that part. So geometrical meaning. So first of all we should take one example of a linear polynomial. Suppose given y is equal to x minus 3. Y is equal to x minus 3. So in junior classes, how we are solving it? So we are solving it by graph. What we are doing? We are doing like this: x, y, x comma y. Now we are taking 3 points. Now let's say x is equal to 1. So 1 minus 3 is equal to minus 2. 1 minus 2. Now it is taking suppose 2, then 2 minus 3 minus 1, 2 minus 1, 3 minus 3 0, 3 0. I have taken 1 2 3 positive values I have taken. So now I will plot this in the graph. Now x dash, y dash. This is not up to the scale, I will tell, because this rough I am doing 1 2 3 4, 1 2 3 4, minus 1, minus 2, minus 4, 1 2 3 4, 1 2 3 4, minus 1, minus 2, minus 3, minus 1, minus 2, minus 3. Now I will plot the points. 1 minus 2, 1 minus 2, this is my point. 1 minus 2, 1 minus 2. Now second, 2 minus 1, 2 minus 1. Here is my point, 2 minus 1, 2 minus 1. Third one is 3 0, 3 0. This is the point, 3 0. Now the linear graph. I will join the points. Okay. Now this is the linear graph. So this graph already we know, we are doing in the junior classes. Linear graph. Linear graph. Here in this graph, the line meet the x-axis at the point 3 0, 3 0. So where the value of x is equal to 3, there the value of y is equal to 0. Here, so for which value of x comma y is equal to 0, it is called the zero of the polynomial. Now here our 0 is what? Then here our 0 is 0 of the polynomial px is equal to x minus 3 is 3. So otherwise what we are doing? X minus 3 is equal to 0, that implies x is equal to 3. There we are doing like this. Previously, now in geometry we are finding what? For which value of x, y is equal to 0. Where are you? Y is equal to 0? At x-axis. Remember, at x-axis the value of y coordinate is always 0. Now we'll discuss more about it. So now move on to the next discussion. Now how to find out the 0 of the polynomial in the graph. 0 or zeros of the polynomial px in the graph. Zeros of the polynomial px in the graph. So what do we write? X coordinate is called abscissa of the point or points where the graph intersects the x-axis is called x coordinate abscissa of the point where the graph intersects the x-axis is called the zeros of px polynomial x. So x coordinate, there from the previous example we got 3 0 we got it 3 0. So this is the x coordinate, this is the 0, we got it. So x coordinate or abscissa of the point where the graph intersects the x-axis is called the zeros of px. Now the graph of the polynomial px will intersect the x-axis maximum at the point equal to the degree of the polynomial. The graph of the polynomial px will intersect the x-axis maximum at the point equal, or we can write at the points equal to the degree of the polynomial. That means what? So linear polynomial, we have what? Then quadratic polynomial. Now your cubic polynomial, and bi-quadratic polynomial. So maximum zeros. How much? Linear polynomial maximum 0, 1. Quadratic polynomial maximum 0, 2. Cubic polynomial maximum 0, 3. Bi-quadratic 4. Because equal to degree of the polynomial. Maximum is the degree of the polynomial. So degree of linear polynomial is 1. So maximum 0 is 1. Minimum also 1 for linear polynomial. For quadratic polynomial, maximum 2, minimum 0. Cubic polynomial, max degree 3, maximum 3, minimum 0. Bi-quadratic polynomial, degree 4, maximum 4, minimum 0. So now we will draw some graph to explain it better. Now move on to the graph section. So for more discussion, I have taken exercise 2.1. This is your exercise 2.1. So bit I see here in this graph, is there any intersection in the x-axis? No, there is no intersection in the x-axis. So no zeros. No zeros. Now come to the double I bit. At how many points the graph intersect the x-axis? How many points? How many points? Only 1 point. So 1 0 1 0. Here coming to the bit triple I, at how many points it intersect the x-axis? 1 point, 2 point, 3 point. So 3 zeros. 3 zeros. How many zeros? 3 zeros. Here, move on to bit 4. 1 point, 2 point. At 2 point, the graph intersect the x-axis. So 2 zeros. 2 zeros. Here, move on to bit 5. At how many points intersect the x-axis? 1 point, 2 point, 3 point, 4 point. It is 4 zeros. 4 zeros. So now move on to bit 6. At how many points? 1 point. Here is the second point. Here is the third point. So 3 zeros. 3 zeros. Now from this graph we can conclude that this is constant term. No. Here is 1 0. A linear polynomial. 3 0. Cubic polynomial. This is 2 0. Here a quadratic polynomial, 4 zeros, bi-quadratic polynomial, 3 zeros, cubic polynomial. But sometimes also we know in polynomial, suppose this is given in this case, here, this like this, and x, x dash, y, y dash, your graph is like this. No zeros. It is also no zeros. So whatever it may be. So here, now we'll move on to the next part of this chapter polynomial. So thank you for watching, and now till yet if you have not subscribed my channel, kindly subscribe it and give your valuable comments and press the bell icon to get my new uploaded videos. Thank you.